Okay, we're going to do something today called conditional probability. We spent the last 2 days doing some statistical stuff. Now I want to move on to some probability ideas. And this first one is conditional probability. And first of all, what conditional probability means is it contains a condition that may limit the sample space for an event. So it contains a condition that may limit the sample space for an event. That's what conditional probability means. Here is how it's written. It looks like this. It's got that vertical line in it. And it's read the probability of B given A. It's the probability that B happens given the fact that A has already happened. Okay, that's what it means. That's what it means to be a conditional probability. There's a condition being put on that probability. Okay, so B is going to happen given that A already happened. So let me show you some examples of this. Here's the first one. It says the table shows the results of a class survey, and it says, did you do a household chore last night? And they broke it down into yes and no, and they broke it down into male and female. So 7 males said yes, 8 males said no, 7 females said yes, 6 females said no. Okay? And here's how this probability works. It says, find the probability that the person did a chore given that they were male. So we're no longer looking at the entire sample space of all 28 students. We're only looking at the sample space of the males because it was given that we're looking at the male students. So out of these, this is the only sample space I'm looking at now, what's the probability that they did a chore? 7/15. 7 out of the 15 males did a chore last night. Okay? So instead of looking at the entire sample space, I'm only looking at part of it. Does that make sense? Okay? So this next one says, find the probability that it's a female given that they did a chore. Now this time on my chart, I'm not looking at the entire sample space. I'm only looking at the part that did a chore. Do you see where the people did a chore up here? Where is it? It's that yes column, isn't it? The yes column is the did a chore column. So if you only look at that, what's the probability that you pick a female? 1/2. 7 out of 14 or 1/2. Do you see how this conditional probability is limiting the sample space? Neither probability did I look at all 28 students. Does that make sense? You see how that's working? Let's try another one. Okay, it says Americans recycle increasingly more materials through municipal waste collection each year. The table shows recycling data for a recent year. Find the probability that a sample of recycled waste was paper. And here we've got all this stuff. We've got, here's the recycled column, the not recycled column. And paper, 36.7 million tons were recycled, 45.1 million tons were not. Okay, 6.3 million tons of metal recycled, 11.9 million tons not, so on and so forth. Okay, they want us to find the probability that a sample of recycled waste was paper. Yes. Now, how'd you get 124.7? You added up all just the recycled stuff? Okay, absolutely. Now, the thing about this, and you got one step ahead of me, is that this one isn't worded the same way that I worded the last ones. It didn't have that word given in there, which sometimes makes it a little bit tough. It says, find the probability that a sample of recycled waste was paper. So we're really finding the probability that the waste was paper given what? Given that it was recycled. So you're only looking in the recycled column, which is in fact 36.7 over, now what did you say the bottom number was? 68 point, yeah, I thought you said something else, but 68 point, just plain old 68, okay. And let's change that into a percent just because that would be a little bit more helpful when we're dealing with millions of pounds of things. Let's get an approximate percent here. About 54%, yep, that's what I had also. Okay. Could you do the same thing if it said, find the probability that a sample of recycled waste was plastic? It'd be pretty much the same thing, except the numerator would be 1.4. Yeah, about 2.1%. That's what I ended up with also. Okay. Okay, any questions on how to do that so far? All right, so right now what we've been doing is just looking at these charts, and it's been, I'm hoping you've been able to see how you've been able to limit the sample space. There is, however, of course, a little formula, and says this, the conditional probability formula. For any two events A and B from a sample space with the probability of A not equal to 0, you're going to see why the probability of A can't be 0 here in just a second. The probability that B happens, given that A has already happened, is equal to the probability that B and A happened over the probability that just A happens. That's why the probability of A can't be 0. Because we know we can't divide by 0 there. So I have an example that I'm going to put up here. So here was the question. The question that was asked was, do you own a pet? And here were the results. It was broken down into males and females. And then they could either answer yes, or they could answer no. And the outcomes were 8 females said yes, 6 females said no, 5 males said yes, and 7 males said no. And here's what I want to do using that little formula. I want to find, oh, that was last hour. It was in here. Okay. I want to find the probability that you own a pet given that you're female. Now raise your hand when you think you know what this probability is just from what we've already done. What's the probability that you own a pet given that you're female? What do you think? 8/13. Does everybody agree? 8/14. So female, there are 14 females, right? And 8 of them owned a pet, so 8 out of 14. I agree with that. Now let's see if we can use the formula. The formula says, in order to do this, the probability that you own a pet, given that you're female, it says up here that we have to do this. Find the probability that you own a pet and you are female over the probability that you are female. Okay, so looking at that chart, looking at that whole chart and the whole outcomes, what's the probability that you own a pet and you are female? 8 over what? 8 over what? Wait. Own a pet and are female. How many of those up there own a pet and are female? 8 out of how many? There's more than 14 up there. It's the whole chart. I didn't say given anything. It's out of 26, right? The entire sample space is 26. Out of this chart, there are 8 26 that own a pet and are female. So this numerator is 8 out of 26. Now we're looking at the whole chart again. There are no conditions put on these, right? On either of these two in the formula, neither of them have a line. There are no conditions. What's the probability that you're a female? 14 out of 26. The nice thing about this is they both have the same denominator, right? And you know when you divide two fractions, it's just like multiplying by the reciprocal. So we have 8 over 26 times 26 over 14, which is 8 over 14, which is exactly what we did before. Okay? Okay, do you need to use the formula if you have a chart? No, right? If you have a chart, it's just as easy to do what we've been doing, right? Just restricting the sample space and getting your probability from there. That's how I would do it. But you might find yourself needing this formula in other situations. Let's see. For example, it says 80% of an airline's flights depart on schedule. 72% of its flights depart and arrive on schedule. Find the probability that a flight that departs on time also arrives on time. Find the probability that a flight that departs on time also arrives on time. Okay, so here's what I want to do first. Is this a conditional probability? Is there a condition being placed on it? It doesn't say the word given that, but is there a condition? What's the condition? The condition is, it says find the probability that, what's the condition? What has to be true about this plane? It has to what? It says find the probability that a flight that departs on time also arrives on time. So yeah, what's the condition? That it departs on time. So given that it departs on time, what are we trying to find the probability of? That it arrives on time. Okay? Now, you might want to use your little formula. The formula says that this thing is equal to the probability that it arrives on time and departs on time over the probability that it departs on time. Okay, well, let's read up in the problem. Do we know what the probability that an airplane arrives and departs on time is? Yeah, it says 72% of its flights depart and arrive on schedule, on time. So 0.72. Do we know the probability that it departs on time? Yeah, 80%, right? So what are you going to get from this? Yeah, 9.9 or 90%, right? So it looks like that 90% of the flights that, given that they departed on time, they will also arrive on time. Okay? Does that make sense? Everybody see what's going on there? Okay. So far, so good. Everybody sticking with the conditional probability? Because up until now, I think it's been pretty good. But I'm ready to throw the curve at you. Yeah. Oh, yeah. I see what you're saying. 72 and 80. Yeah, is that what you said? Yeah, that would be fun. Any questions so far about this conditional probability? Okay, and I have 2 more examples to show you. Here's the first one. It says a student in Buffalo, New York made the observations below. of all snowfalls, 5% of them are heavy, meaning they get at least 6 inches. After a heavy snowfall, schools are closed 67% of the time. After a light, which means less than 6-inch snowfall, schools are closed 3% of the time. Here's what I want to find, first of all. The first thing I want to find is the probability that the snowfall is light and the schools are open. And then I want to find the probability that the schools are open given there is a heavy snow. Those are the two things that I want to find. Okay? Now, as it looks right now, I think it's pretty hard to find all this information. So what we're going to do is we're going to organize it into a tree diagram. Now, I know you've done tree diagrams in the past, okay? Although this one is going to be a little bit different than what you're used to, because usually when you made them, I think you're used to having the same probabilities on all branches. But it doesn't have to be that way. So to start out with, we're going to have 2 branches. Any ideas how we're going to label these 2 branches? Okay, heavy snow and light snow. Okay? All right. What's the probability that the snowfall is heavy? 5%. Isn't that what it says? So on the heavy snowfall, I'm going to put 0.05. I'm always going to change these to decimals. So if 5% of the snowfalls are heavy, then what about the light snowfalls? It's going to be 95%. Is everybody with me so far? Now, in either case, for both a heavy snowfall or a light snowfall, there's a possibility that what could happen? School could be closed, right? We've had that before, right, where they're predicting a blizzard and say they call off school and then the blizzard doesn't hit, right? That's happened. I guess there are a few instances where they say the blizzard, they don't even predict the blizzard, but it shows up anyway and they don't call off school, and maybe they should have. So it can go both ways, right? So off of here, I'm going to say, we'll say no school or school. Now, if it's a heavy snowfall, there's no school 67% of the time, which means there's school 33% of the time. The same thing can happen down here. We can either have no school or we can have school. If it's a light snowfall, school's called off 3% of the time. So 3% of the time there's no school, meaning 97% of the time we still have school. Okay? Is everybody with me so far on my tree diagram? Okay. So the first one says, problem number 1 up here says, find the probability that the snowfall is light and the schools are open. So we're supposed to find the probability that we have light snowfall and the schools are open. Light and open. Is there a given condition here? No. We just want to find out if it's a light snowfall and the schools are open. What are the chances that that happens? Well, first of all, light snowfall happens 95% of the time. Of that 95%, school is open 97% of the time. Thank you. Here it is. I'm sure the math one's in there somewhere too. All right. So, any ideas how I'm going to get that total probability? Yeah. All I have to do is take my 2 probabilities and multiply them together. So it's going to be 0.95 times 0.97, and that's going to give the probability that it's light and schools are open. And that is 92.15%? Is that what other people are getting? Okay. Okay, let's see if we can find out the second one. It says we're supposed to find the probability that schools are open given that there is heavy snow. So, probability, I'm just going to write open, probability that school is open given heavy snow. Now, again, on this one, it's not so easy just to narrow down the answer. What I think you need to do in a case like this is use the formula. And to use the formula, we first want to find the probability of what? Okay, that it's open and heavy over the probability that it's heavy. Okay? All right, open and heavy. Well, I don't have to do it in that order, right? Because my tree diagram's set up the other way. So I'm going to do heavy and open. So to get heavy and open, what am I going to have to do? Okay, 0.05 times 0.33. And that's going to be over the fact that I have heavy snow. What's heavy? 5%, 0.05. You probably don't have to do too much here because as soon as you set it up, I'm hoping you see what it's going to be. 33%, right? Because the 0.05s go, and we end up with 33%. Okay? Do you see how that works? Yes? Sometimes you can. On this one, it limited us to the heavy. So I know that heavy snow has occurred. So from this point, what are the chances that school is open? 33%. Okay? It's not always quite like that. I think I've got another one on here that will show that. In fact, let's see, maybe we can just do one with this tree diagram. Let's find the probability that the snow was light. Let's find the probability that the snow was light given that schools were closed. Okay, let's find out the probability that the snow is light given that the schools were closed. So this means we're going to do the probability of light and closed over the probability that they were closed. Is everybody with me? Okay, how do we get light and closed from up here? It's going to be what? Okay, 0.95 times 0.03. So we're going to have 0.95 times 0.03. Now this is over the probability of closed. How do you get the closed up here? How do you get the probability that the school is closed? Unfortunately, I can't quite do that because those are on different branches of the tree diagram. So I can't multiply them like that. How can school be closed? It can either be heavy snowfall enclosed, or it can be light snowfall enclosed. Since there are two ways that school can be closed, I have to account for them both. I'm going to find the probability that it's heavy enclosed. I'm going to find the probability that it's light enclosed. And guess what I'm going to do with that to get the total probability of being closed? Add them together. Well, we already know light enclosed. We already did that one. It was 0.95 times 0.03. Plus, now let's do heavy enclosed. So what are the probability that it's heavy and closed? 0.05 times 0.67. So 0.05 times 0.67. Okay, now you need your calculators. And since I just made this one up, I'm going to need your help. So what's the top? What's the numerator? 0.95 times 0.03? 0.0285. So on the bottom, I'm going to have 0.0285 plus 0.0335. Okay, so now I have 0.0285 over 0.062. Is that right? Is that right? Yes? Okay, so now go ahead and divide them and you get what percent? 46? 46%? So there's a 46% chance that the snow is light given that they closed. So just because school is closed, almost half the time the snow is light, they probably could have gone. Right? That's what this is saying. This type of probability is used a lot in the medical field when it comes to doing tests for certain kinds of diseases. They use these same kind of probabilities to kind of check the validity of their test and to make sure that it's doing what they want them to do. All right. Would you like to do another tree diagram, or are you good? Are you sure? Does anybody want a tree diagram? These are the trickiest ones that you're going to have. One more. Okay. It says, on 28% of the days, the sky is mostly clear. During mostly clear days, it rained 4% of the time. During cloudy days, it rained 31% of the time. Okay, so what do you think our two branches are going to start off to be? We'll worry about these in a minute. Okay, what is it? Okay, mostly clear and cloudy. So, mostly clear and cloudy. Okay, and mostly clear happens 28%. That means cloudy happens 72%. Now, off of each of these, what could possibly happen? Okay, rain or no rain. Okay, so on the mostly clear days, what's the percent that it rains? 4%? That means no rain, 96%. On the cloudy days, we get rain, 31%. That means no rain, okay, 69%. Okay, so the first one says, find the probability that a day starts clear and then it rains. It's clear and then it rains. Is this a conditional probability? No, we just have the probability that it's clear and rains. What do we do in a case like that? Yeah, so clear is 0.28, and then it rains would be giving us, what is it? It's a pretty small probability, I think. Yeah, it's 0.01, so it's about 1%, right? 1% of the time that happens, okay? And the next one says, find the probability that we get rain. How can we get the rain? There are two ways to get rain. It's either, how can we get rain? Okay, we can have mostly clear and rain, or we can have cloudy and rain. What are we going to do with those two probabilities? Add them. We already know the mostly clear and rain. That was 0.01 plus How do we get cloudy and rain? 0.72 times 0.31. That's what, the whole thing?
No,
Just this one is 0.2232 plus 0.2232. So it looks like it's going to be, what, about 23%? 23.3%. Okay. Do you see how that works? Could you find the probability of rain given that it was cloudy? Is this an easy one or a hard one? It's pretty easy, because if it's given that it's cloudy, you know you're sitting right here. What are the chances of rain now? 31%. Okay, does that make sense? Any other questions? Okay, then I'm going to put up your assignment, and then I will answer homework questions, and then the rest of the time you can work.